So, quiz number 2. We'll do my old joke. I don't know, some people think it's funny. Some people just don't get the joke at all. The recording timer makes 225 dots in 5 seconds. What's its frequency? There's our Doppler effect. Recorded for posterity on the internet. Strange enough, Nick. Oh, did I say your name? Shoot. I don't want you to do a software update right now. I know there's a new update of Java, but I can't install it because the district school provincial software is too crappy. Frequency. Now, frequency, we said, was measured in hertz, which is the number of times per second. 225 dots per second. You get a frequency of 45 hertz. Half mark for the 45, half mark for the unit, hertz. If you said dots per second, I'm taking a half mark off. It's hertz. Recording timer makes 625 dots in 10 seconds. What's the length of time? So now they want the length of time, which is also the reciprocal of frequency. I'm going to go 10 divided by 625, which I think ends up being 0.016. Is that right? I'm going from memory here. That one I didn't do in my head. That one I remembered the answer. Seconds. Car travels 40 kilometers in 30 minutes. What's its average speed in kilometers per hour? So speed is distance over time. You okay, Cliff? Question? Or Doug?
No, we went like frequency equals 625 divided by 10, and then we got the hertz, and then we just put it.
Did you get 0.016?
Yeah.
I don't care. Good. Got the right answer. Yeah. By the way, there's always more than one way to get to a lot of what I'm showing with you guys. And then if you bring in calculus, there's way more ways. I'm going to put a distance of 40. I'm good with that. Why can't I put a 30 on the bottom? Because I can't. So 30 minutes, how many hours? I gave you a nice easy number. 30 minutes, how many hours? Yeah, 0.5. And I think you end up with 80 kilometers per hour. 1 mark. No units, half mark off. Took me 30 minutes to get here, traveling at an average speed of 80 kilometers per hour. How far? By the way, the new equation that we have is this, but in Science 10, you weren't really looking at acceleration, which is why you had that equation, which is true for a constant speed if the acceleration is 0. It's going to be speed times time. It's going to be 80 times 0.5 again. I traveled for 40 kilometers. That gets you a half mark. They wanted an answer in meters. So for 1 whole mark, 40,000 meters, please. Check your units. Number 6, what is the equation of this graph? Use proper variables in units. So I'm going to base it on y equals mx plus b. But I'm not going to use a y. I'm going to use a d, because that's what's sitting on my y-axis. And I'm not going to use an x. I'm going to use a t, because that's what's sitting on my x-axis. Oh, and I can get the y-intercept. It's 4.63. I can tell you that right now. What I need to do is find the slope. Okay. Really, I'm looking at this right here. Doug, my friend, how high is point B? How high is point A? What's the rise between those two? If I go, what's the rise? 40 take away 12, which is 28. Over. What's my run? Well, here I'm at 24. Here I'm at 5. 24 take away 5 is 19. Now, if you wrote 28 over 19, that gets you full marks. In math, we like the fraction version. However, in physics, we usually like the decimal version. You'll notice I went to a decimal here. So I would also have no problem. And in fact, in physics, I would prefer 28 over 19. How about 1.47 or 1.5 to 2 sig figs? I'm going to go 1.47 t. The reason we like that is that number means something. That's the acceleration, because it's actually Sorry, that's VI, not my acceleration. This is a graph of distance and time. It's VI. Yeah. What did I say? I did say it, so you just like me to repeat things? Repeating things is preferable to you? If you had your way, you would prefer it if I said the same thing for a second time in a row? Your learning style is such that when someone says something for another time in a row, that assists you in your learning style? I'm going to be flogging that to death all class, Doug. Oh, you walked into it. So this quiz is out of, count 'em, 6. Give yourself a score out of 6. Pass them in. Those of you that were away, hand your quiz in with your name on it with a big omit. Otherwise, you get a 0. So, quiz out of 6. Last day, we looked at constant acceleration. We finished off, I think, did we not, the lesson? And I said to you I would take questions from this homework. I know it says lesson 8. I'll fix that. It's lesson 5. This was the homework from the constant acceleration assignment. And I also gave you a sheet called Using the Constant Acceleration Equations. I'll take a couple of questions from there if necessary. What I want to do today, Kelly, is we want to look at some applications of acceleration. We want to look at a couple of neat RCMP type engineering questions. We'll look at free fall. Yes, I'll be showing you a video of me jumping out of an airplane a bit later on. And then that'll take us to Thursday. Thursday, we're really going to flog free fall. Free fall, A, it's a great physics application. Hey, you're dropping something. B, it's something all of you have seen, things falling through the air. So it's and I think all of us are kind of interested in it. So any questions from this here assignment? I assigned 1, 2, 3, and 4. Any of these that you were going, I have no idea how the heck they got these answers over here. Now is your chance to ask. If you didn't do it yet, it's going to be due today. Going once.
Unit 3, lesson 5.
Pardon me?
Unit 3, lesson 5.
I don't know. Unit 3, I don't know what you're talking about. Okay, this is the homework, yes? No, well, no, it's, okay, you ready, Enzo? Apparently you need to repeat things too. It's lesson 5, but I know the homework itself says lesson 8. But you're looking for this handout here called Constant Acceleration Equations. I gave you 4 questions at the end. Any of these you want me to go over? Going once. You with me now?
Yep.
Boy.
I was on the same one.
Yeah, I totally care. Okay, if you have that done, if you want to hand it in, otherwise hand it in next class or hand it in before class is over, and we're going to move on. So what we want to look at are some neat applications of acceleration. We're going to do a couple of engineering RCMP questions, and then we're going to jump into free fall, which is a great application of acceleration because you may have noticed that objects speed up as they fall. And if they're speeding up race, that means they're accelerating. What's going on there? But let's start out with some engineering ones. I'm simplifying these a little bit, but that's okay. Example 1. I looked this up. A jet airliner needs a takeoff velocity of 288 kilometers an hour in order to safely leave the ground. If a jet's engines can accelerate the jet forward at 3.50 meters per second squared, I double check that, those numbers are reasonably accurate. What is the minimum length of the runway? Okay, so you're an engineer designing an airport. Now, in real life, Cliff, we would also have to take things into account like the dominant wind direction, and we would build in a huge safety margin. So once again, I'm teaching you garbage, but they would start here. And then they would get more complicated. We'd have to take factors into where are the nearest houses, what angle are we going to point the runway at, all that stuff. Not worried about that. All right. What's this question asking me to find? Let's defic. What's it asking me to find? Distance? Sure. Now let's walk through and let's see what they gave me. 288. What's that? V final? Now, I got a problem with that 288. What's my problem with that 288? Greg? Per? So I'm going to write down the units. Usually when I write down the units, that's my way of saying to me, I don't like them. If I like the units, Sean, you may have noticed, I just don't bother putting them because I'm happy. I sometimes do. I'm not consistent on that, but I know when I don't like them, I always write the units down. I'm going to have to fix that later. We'll come back to it. I see a 3.5. What's that? It's an acceleration. Right now, I know two things, and they're asking me to find a third. Can't be done. You may recall I told you the other day, you need 3 to find 4 in this unit. So there must be something else that's either I can figure out or reason my way to, or it's in English, not a number. What else do I know? Yeah. What's VI? We are going to, I think, rightly assume that planes start out from rest, which they generally do. I have been on one plane where the guy turned the corner and without slowing down, gunned it right away, but only once. And I'm guessing that we were behind and they was just, hey, we can sneak us in right now. But every other time they've come to a complete stop, they do some kind of a checklist in the cockpit, I'm sure, and then away they go. I don't like that 288. We're going to change it. Now, put your pencils down, look up. This is one time, because this is by far the most common unit conversion of this whole course, going from kilometers per hour to meters per second. This is one time, Doug, I'm going to say, here's a shortcut worth memorizing. Because you do it all the time. So I'm going to derive it once, and I'm going to say, here's the trick, and we'll write it down. What was it, 288? Kilometers per hour. Now, if I was converting this, I would say I got kilometers on top, so I want kilometers on the bottom, meters on top. And I would say, oh, that's 1,000 meters is 1 kilometer, and that would take care of the kilometers. And then I would say, okay, I got hours on the bottom, so it's going to be on the top. I want seconds. How many seconds in 1 hour? Have we learned that one yet? And I would go like this. What I want you to notice, Amanda, is that it looks like it's really 1,000 divided by 3,600. In lowest terms, it's really, and this is going to be our shortcut. Pick your pencils up. We have room right next to DFIC up here. If we want to go from kilometers per hour to meters per second, divide by 3.6, which is a fairly easy number to remember in our base 60 time scale. 60 minutes, 60 seconds. 6 times 6 is 36, 3.6. By the way, that goes from kilometers per hour to meters per second. What if I want to go from meters per second to kilometers per hour? Times by 3.6. If I'm doing rough math in my head, to be honest, I multiply by 4, and that's roughly kilometers per hour. Oh, or if you double it, that's roughly miles per hour. This is how I often call, you'll see me go, my eyes will go glazed for a second. What I'm really doing is doing a quick math to see if the numbers make sense to me, because I'm used to driving in kilometers per hour, so whatever answers we get, I know about how fast that is compared to how fast I drive. So, divide that by 3.6. How many meters per second is 288? Even? Yeah, I could. It was. By the way, the actual numbers I think were like 295. I made it 288 to get nice numbers. So 80 meters per second. I'm looking for an equation that has D, V final, A, and V initial in it. Oh, and no time, please. Which one? I think there's only one that doesn't have T in it. Doug, which one? Doug, which one? Good repeating. Doug, what are we trying to get by itself? What are we trying to get by itself? The variable that we're trying to get by itself is what? D. Let's see if we can do that. How would I get that by itself? How would I isolate the D? How would I remove all of the variables to the other side, Doug? Talk me through it. Yeah, I got that, Captain Obvious. That's what I've just said. That's repeating what I've just said, which somehow rings true. Okay, so I want to get this by itself. I'm going to move this over, but later. By the way, have you noticed, how many of you know what bed mass means? Remember that from your math days? When you're equation solving, because you're going backwards to find the original starting point, it's always reverse bed mass. You do the addition subtraction first. Then you do the multiplication. Actually, if you want an acronym, it's felt sad. Fractions, exponents, like terms, subtraction, addition, division. If you don't do it right, you'll felt sad. LT is like terms.
Oh.
Gather like terms. If I was teaching Math 9s, that's the acronym I would use. I haven't taught Math 9s for years, but that's what I used to do. And then whenever someone got it wrong, we would say, are you felting sad? Right, that was the way to reinforce the order. So I'm going to divide by 2 later. I'm going to move this over. I always do the addition subtraction first. Doug, how do I move this over? Minus it. So I'm going to have this minus that. Yes, 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 yes. Divided by. Can you visualize it without me showing work? Let's see if we can get there. It's going to be that minus the VI squared divided by the 2a. So if I hear you correctly, you're saying it's going to be VF squared minus VI squared over 2a. When I isolate the variable, I'll get VF squared minus VI squared over 2a. Good. Do you ever have deja vu? Do you ever have deja vu? No, cheap joke. Explain it to Nick. He didn't get it. Keep going, Doug. What's V final?
V final is 80.
Squared? By the way, the most common mistake with this equation, it drives me crazy, kids forget the squared. They write them in the actual formula. They always get the previous line right. And then for some reason, when they start sticking in numbers, they're so proud, Joel. They rewrote the equation. They're so proud of themselves. They forget to actually plug stuff in correctly. Minus 0. What is 0 squared? So I'm going to, here, I'll put the squared, but I'm not going to type it on my calculator. All over 2 times 3.5. By the way, Doug, am I traveling forwards or backwards? You've been in an airplane? Am I expecting a positive or a negative answer? So there's built-in error check. We've just got rid of half of the wrong answers because half the numbers out there are negative. If I get one of those, I've typed something wrong. How many numbers on the... Oh, you know what? I'm going to be lazy. Doug, what is 80 squared minus 0 squared? What's anything minus 0? Anything minus 0 is 0?
No, anything.
So I'm going to go like this. 80 squared. I'm not going to type the minus 0 squared. Divided by. But there is 2 numbers on the bottom. Better use brackets. And I get, what, 914 meters long? I'm not going to worry about sig figs here. Although 3 sig figs, I guess, is what I would go to. Now, Abe, that's bare minimum. That's assuming you start with your back tires on the very, very end of the runway, almost sticking into the grass. There's no way they'd build it. You know what? They'd probably double it, minimum. You build the runway at least 2 kilometers long. In fact, Brad, I wouldn't be surprised if they triple it, 3 kilometers or something like that. There's your safety margin. But here's where they would start out, certainly. Okay. So there's one nice application. Another place this is used is in accident investigations. So here's another good example. Example 2. RCMP officer is investigating a car crash. At the scene of the accident, there are skid marks that are 32.5 meters long, easy to measure with a tape measure. Obvious on the pavement. The driver of the car was speaking on a cell phone during the accident. Oh, please, nobody has accidents while they're talking on a oh, yeah, okay. Happens more often than you think. And the cell phone records the sound of the skid for 1.2 seconds. You can hear the high-pitched whine of the skid. The speed limit on the road was 60 kilometers per hour, and the driver claims that he wasn't speeding. Can the RCMP charge him? Or if you're this driver's defense lawyer, have you got a good defense that you can prove this guy wasn't speeding? What's this question asking us to find? Think about this one very carefully. How fast? Except we don't have the word fast on our... And don't say velocity. Which one? Right? Now we're back because there's 2. What?
Final.
Oh, I've heard both. Why is final velocity not what they're asking me to find? Don't you all know the final velocity right now?
0.
So, see how we put that all together? Abe said, how fast? I said, give me a physics term. You said, well, it's a velocity. Which one? Well, it's either final or initial. Final 0, got to be, by default. Right? VI. Now let's list what we know. What's that 32.5? It's a displacement or a distance. And I like the units. What's that 1.2? That's 60 kilometers per hour. Am I actually going to use that? I think they gave that to me, Maddie, for a comparison. So I need one more thing. Oh, what else did we say we knew? VF is 0. So I'm looking for an equation that has VI, dt, and VF in it. Which one? Roy, which one? Don't pick one that has an A, because we don't know that. They're all 4 in a row there. You see them, right? So read the one that doesn't have an A in it. Yep, that one. Keep going. Are any of these values 0? Oh, so you're saying, Doug, what's VI plus 0? Just plain old VI. What's VI plus 0? Just plain old VI. So, Doug, if I hear you correctly, you're really saying this is D equals a half just VI times T. Okay, cool. Are you starting to buy in why I'm trying to get you to master formula manipulation and not memorize this variation of the equation and every other variation of the equation? Don't do that. Not worth it. And even if you're a little shaky on the formula manipulation right now, trust me, it'll become like in your head, walking, falling asleep, falling off a log, piece of cake. Okay, but how would I get the VI by itself? Let's go one thing at a time. What's the 1 doing? Do I care about the 1? No. What's the 2 doing? It's on the bottom, so it's dividing. How would I move it over? Times. What's the T doing? So how do I move it over? Yep. So if I hear you, you're saying this. It's going to be 2 times D divided by T equals V. Can I put the VI over on this side because we're used to seeing it on the left-hand side? Equals VI. There's another equation. Don't memorize it. Well, you can. Nothing prevents you. Knock yourself out, but you'll literally knock yourself out. Your brain's only got so much room. Oh, let's crunch the numbers. Let's see. 2. D was 32.5. T was 1.2. And let's go to 3 sig figs. What do you get? $54.2. Was he speeding? Oh, wait a minute. Units. Units. This is meters per second, boys and girls. Oh, ahem. How do we go from meters per second back to kilometers per hour? How fast was this guy going in kilometers per hour? Has he got a leg to stand on with the RCMP, even if there is some error in the measurement, even if there was slick roads, even if like any argument coal that a lawyer wanted to try and make, how fast was this guy going? And by the way, this is minimum, because he could have braked for a while without skidding, right? He could have started to slow down, and then panic stopped and skidded, which means he could have already pulled a bunch of his speed off already. How fast? 195. He's street racing, right? He'd get charged. He'd get his car impounded. You know what? In fact, I'll even bet you what this guy was doing. Street racing, talking to the guy he was racing with on the cell phone at the same time, right? Pardon me? It all depends. Yeah, okay. You sound so familiar with that. Oh, okay. I have a friend who had his car impounded. Yeah. Actually, one of the best lessons I ever did, this about 6 years ago. One of my kids was in a car accident driving stupid. And so this was later on in the year when we had more physics skills. We analyzed the heck out of it. It was great. No. Sean who? Don't think so. Doesn't ring a bell as the guy's name. But who knows? I'm getting old. The mind goes first, then the hair. Okay. Oh, so if you're this guy's lawyer, you're copping the plea, right? You do not want to go to court because all of you gasped when you saw that number because it's really close to what?
200.
You think the jury is going to have the same reaction? Yeah. Right? Again, Jacob, I've simplified things. There is more to the RCMP crash analysis than just this, but this is where it starts. We would have to take things into account like, okay, what type of pavement, what's the coefficient of friction, is it raining, what kind of tires, but yeah, this is pretty close to begin with. Third application. By the way, I like both these questions. They're nice questions. I like them both because, hey, good applications for a change. Wow, math that people might use in the real world. Who knew? And they're nerdily cool. And I think one of these you'll see in the future. Free fall. Near the Earth, objects in a vacuum, if we ignore air resistance, in a vacuum, fall to the Earth with the same acceleration. Behold, right there. Was it speeding up?
Yes.
It's accelerating. Now, we're ignoring, and we're going to ignore, air resistance. We're going to assume whenever I'm dropping something, it's a heavy ball bearing made out of steel, nice and round. We're going to assume I'm not dropping this. Because that did accelerate, but nowhere near the same rate. Although if we sucked all of the air out of the room, and we were all wearing spacesuits so we didn't die, and you dropped that piece of paper, it would go thumping down because it's air resistance that's slowing it down. I have a video, but not today. Turns out, everything near the Earth, and by near the Earth, Brad, I really mean within about 1,000 miles of the Earth. So in outer space, space shuttle orbit's only about 100 miles up. So even on the space shuttle, they're in the Earth's gravitational field. And because it's the acceleration due to gravity, we use the letter lowercase g to represent it. G has been measured over and over, negative 9.80 meters per second squared. Negative 9.8. This value, Greg, is on your formula sheet. All of you will end up memorizing this one. In fact, it'll be if I see you 5 years from now, and if you do physics 11 and 12, probably the one thing you'll still remember is G. We use this all the time. By the way, what nice number is that really close to? If I'm doing the math in my head, because I am a nerd at amusement parks, I do try and calculate G forces and things. I use 10. Why the negative? Down. Down. Okay. Outside of a vacuum, air resistance can dramatically lower G, but we're going to ignore it. We're going to pretend we got golf balls. Except golf balls have dimples. Those actually have air resistance. Imagine a golf ball-sized piece of lead or steel. Heavy, round, aerodynamic. Example 1. A cannon is dropped from a cliff. It hits the ground 5.6 seconds later. How high? This looks like a job for DFIC. Jenna, what are they asking me to find? Yeah.
How high?
There's no high on my formula sheet. In terms of what we've been listing, what are they asking me to find? Yeah. Probably a displacement, but I always get those two mixed up anyways. So let's write down D equals question mark. Jenna, what else have they told me? Jenna, Jenna, yes?
No,
Janaya. Why am I going Jenna? Jenna, I don't know. No kidding. Good God. You know what? The mind goes first, and then the hair. And apparently I'm going to be going bald any second now. I'm sorry, Janaya. No wonder I'm throwing you off your game. My bad. Janaya, joy of my heart, light of my life, angel in my garden. What else have they told me? What's that 5.6?
time.
I agree. All of us, there's a key word in this question that we're going to underline. Dropped. Because that means we're in free fall. Janaya, as soon as we're in free fall, I will not tell you this. You'll be able to write A equals negative 9.8. I will almost, in fact, I will never put the 9.8 as a number in the question somewhere. Cole, you had your hand up. I ignored you. There's one more thing. What does dropped imply? If you drop something, what is your initial velocity? 0. I'm not going to tell you that either. I'm looking for an equation that has D, T, A, and VI in it. It's not the first one. Cool. D equals VIT plus a half AT squared. And conveniently, the D is already by itself, Greg. I like that. Because this was the yuckiest equation to move around and do math with. Oh, Sean, are any of these 0? What? So you're telling me that this is 0? Why can I do this then and cross that out completely? What's 0 times anything? Gone. So if I hear you correctly, 0.5 times negative 9.8 times 5.6 squared. Good, what do we get? Oh, I get a negative answer, which is okay, by the way. We'll talk about why. You do get a negative. What is 0.5 times negative 9.8 times 5.6 squared? Anyone? Don't all rush for your calculators at once or anything. 50, sorry? Anybody else? 53.664? 53? No, yes? I need some confirmation. You're going to get a negative. I know you're going to get a negative. Negative 153.664? Oh, how many sig figs should I go in this answer, actually? 2. Okay. Negative 150. Why negative? Yeah. Did it end up below you or above you? It ended up below you, and it's telling you that. Now, height, Janaya, technically is a scalar. I would never say, hey, see that cliff? It's negative 150 meters high. So if you said at the very, very end, the height is 150, I give you full marks. I won't, or if you call a height negative, I won't take marks off for that. But for what it's worth, there you go. Any of you ever stood over something high and dropped something and timed it? Yeah? So the shortcut, if you want to do the math in your head, square the time. Put a 10 right there. What's half of 10? It's square the time and then times by 5, and you'll be pretty close to how high the cliff is. You'll be within probably 2 sig figs. Okay. Unless it's really, 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 really high, then there's a delay because the sound takes a while to come back, and you would have to factor that in. You had a question?
Would you also go to final for Cannonball?
That's a great question. That ties us wonderfully into part B. What is the impact velocity of the cannonball? I think in part B, Roy, call me silly. I think they're asking us to find V final. No, that's after it hits the ground. This is the impact velocity, and I'm so glad someone said that, because that's a mistake that drives me crazy. So when we're dropping something and I say to you, find V final, don't you dare tell me 0. What I really mean is the split second it hit the ground, how fast is it going? That's V final. Otherwise, I would be starting at 0 and ending at 0. There's no way I could have accelerated it, right? If my final and initial speed are the same, you're going to get all sorts of dumb, weird results, and you're going to be freaking out because you know something's going on wrong, and that's it. Is that what you're going to ask, Roy? Let's find V final. Okay. Roy, let's find an equation that has T, A, VI, VF. It can have D, but if I can avoid using this, I will, just in case I got it wrong. I think the first one, yeah? VF equals VI plus AT, right? You guys all know, we're looking at, they're all in the same row, right? About 1/3 of the way down, is that right? They're scattered out in other places, but they're all in one nice row there, yeah? Okay. Is the VF by itself already? Oh, great. So we get VF equal VF, Mr. Dewick. Come here. Thinking ahead already. VF equals VI plus AT. Hey, Roy, why can I do that? And are you saying if I want to find the final velocity, I roughly go 10 times the time? Yeah. Oh, but make it negative because it's going down if you really want to be fussy. It's going to be negative 9.8 times 5.6. And even if you don't have a stopwatch, you can do the 1001, 1002, 1000. It's about once every second. You can be fairly accurate. Now, great physics, please don't be stupid. Make sure no one is down below at the bottom of the cliff when you're dropping. If you ever try doing this. So it's a great experiment. I think it's great. Make sure there's nobody down there. Penny, right away, the air resistance plays a huge part. See, if I was on a steep cliff and I wanted to know the height, I would, first of all, I would give it a bit of a horizontal velocity. As long as I don't arc it up, that won't change the answer at all, because I don't want it to hit the cliff part way down. I would use a fairly round, aerodynamic, heavy rock, and I would make sure nobody down there, because I'm not dumb. But Penny's, they hit terminal velocity actually in about 20 feet already, pretty fast, because they start to spin right away. Pardon me? It's a great question. That might be the topic of a Mythbusters episode we'll watch in a few days. Meanwhile, what do we get here? Anyone? Cole? Negative, yes? 54 point what? 88? Sig figs, we would go to 2 sig figs, so we would say negative 55 meters per second. How fast is that? Times it by 4, roughly. It's about 200 kilometers an hour. It would hurt. Pardon me? Well, times it by 3.6. See, that's, I times it by 4 and subtract a bit because 3.6 is the actual number. Tricks of the trade. You know, if you ever wonder how I do a lot of this math in my head, I usually have a pretty good idea where the answer is supposed to be. I'll try to teach you some of those too. Also, that way you know if you've done a dumb calculator mistake. Oh, Roy, you know what? It doesn't even have to be when it hits the ground. I could ask you the velocity at any time. Hey, what's the velocity of the cannonball after 3.6 seconds? So, oh, by the way, I think I said this. You'll notice I didn't re-defic because I had everything right above here anyways. Sure. If I had turned the page, Matt, I probably would have relisted the data really quickly because that 1 second is a good investment. C. What do they ask me to find in C? Are they asking me to find distance? Which one? How do I know it's not the initial velocity? Because what is the initial velocity if I'm dropping it? So what are they asking me to find? V final with a different time. So I'm going to go like this. V final equals question mark, and right away underneath it I'm going to say, hey, Duick, T is 3.6. I might even put a box to really emphasize. Actually, a box usually means that's your final answer. You know what I would do, Race? I'd probably go underline, underline. Don't forget, don't use the 5.6 that you've been using on all the previous questions. Don't be sloppy. In fact, though, now, I think I can drop everything down from part B. I think I can go V final equals, I can cross out the VI, and I can say, hey, it's just AT. Negative 9.8 times 3.6. I can get the instantaneous velocity at any time during its flight. How fast is it traveling after 3.6 seconds? Oh, and I know the answer better be smaller than negative 55. Sorry?
35.2.
Is it negative? Is it negative? Yes, yes, yes. Negative 35.28. Anybody else? So if I go to 2 sig figs, negative 35 meters per second. Reminder on sig figs, I've told you I won't take marks off on tests, but I will try and be accurate here in my work. What else could they ask? Turn the page. Oh. I could ask you, how far has the ball fallen after 3.6 seconds? Okay. How far? Oh. Taylor, what's this asking me to find? D equals question mark. Did we just all turn the page? Let's quickly read DFIC. We're in free fall. Right away, I know A is negative 9.8. Yes? Oh, and I know VI was what? And what else has this question told me? Yeah, I got the 3 points. What is that? Okay. I'm looking for an equation that has D, A, VI, and T in it. Yeah.
A equals VI, D plus 1 over 2 AT.
And conveniently, the D is already by itself. Oh, Cole, if you'd been really, really, really clever, you might even have actually read the equation out as D equals a half AT squared, and I would have been impressed. Why can I cross out the VIT, Abe? What's 0? VI, yeah. Oh, okay. This is going to be D equals 0.5, negative 9.8, 3.6. Don't forget the squared. Most common mistake, forgetting the squared on that line, because kids are so proud they've done all the physics, they forget to do the arithmetic. Can I do this one in my head? Nah. If I had to, but too many decimals. 0.5 times negative 9.8 times 3.6 squared. Do you get negative 63.504? I'll go negative 63.5. Oh, heck, I'll go to 3 sig figs. I know it's 2, but I'm lazy. Negative 64. E. I like this question. I like this question. I like this question. I didn't say it's going to be on the test. You must be a student who notices those things. Good to see you notice something. Doug, behind you on the shelf, can you see it? There's an attention span right there. Help yourself. E. You know, I hope when we do a shuffle, the two of you guys end up sitting next to each other, because that's going to be a table of just great entertainment. Explaining jokes to each other. Yeah. I don't get it. I don't get it squared. Okay. Enzo, can you read E to me, please?
How far
So I'm finding a distance. This is a weird one, though. Keep reading.
How far does the ball fall during the 4th second of free fall?
So it's not saying after 4 seconds. It's saying only during the 4th second. Put your pencils down, look up. We're going to dolp, but my dolp is too big to fit in here. When I start my stopwatch, what's the time on my stopwatch?
0.
So 0 to 1 second right there, that's the 1st second. It's speeding up so it falls a bit further. There's 2 seconds. This right here, that's how far it fell during the 2nd second. There's the 3rd second right there. The 3rd second is actually between 2 and 3 seconds. The 4th second, running out of room, but I can keep going, would be right about here, I think. This is the 4th second. So I want that distance. Anybody have any thoughts on how I could figure it out? Cliff, what? What?
The acceleration is negative 9.8.
It is.
So in 1 second it travels 9.8 meters.
Uh-huh.
Times that by 4.
Glad, Cliff, you made a mistake, a very subtle one. I'm glad you did. Cliff said, couldn't I go 9.8 meters in 1 second times 4? That would be if it wasn't accelerating. But since it's going faster every second, won't it be traveling more than 9.8 meters in the 2nd second? And won't it be traveling even more in the 3rd second? In fact, I think it's going to look something like this. 1st second, 2nd second, 3rd second. Like, I think it's going to be longer and longer and longer each time. It's a good thought. That's a good start. Aaron, you had your hand up.
Find the VI.
could, there's an easier way, so I'm going to come back to you in a second, but I'm going to see what Jamie has.
You could find the distance between 1 and 3 and then 1 and 4.
You know what? You're almost right. I'm going to, he's like, wow. Find distance between 1 and 3. We didn't start at 1. Where do we start at? Okay. I think what I can do, I can find this distance. I can also find that distance. How can I find that distance? Minus them. We're going to find, you know what? I'll call this D4. I'll call this D3 for the distance after 4 seconds, the distance after 3 seconds. And I think this little chunk right here is that. So I can, as it turns out, Jake, find out any distance between any 2 seconds that I want. Let's put that together. Pick your pencils back up. So I think let's divide this up into 3 chunks. And our strategy is going to be, so the distance that we want is the distance after 4 seconds minus the distance or the displacement after 3 seconds. Right? So first, let's find the distance, how far has it fallen in 4 seconds? And conveniently, look right above. Don't I have the actual equation right here? Except instead of a 3.6, what am I going to put in for time? 4. It's a half AT squared because VI is 0. After 4 seconds, how far away from us is it? How far has it fallen? Yep. 34.3. Anybody else? No? Anybody else? You have something different? I think it's something different. I think that sounds a little better to me. I think you forgot the squared, by the way, or something.
Oh, what are we asking for the total?
Oh, I'm not done yet. Oh, you're doing the total? Patience, young grasshopper. Okay, sorry. My bad. Cole, can you remind me to come back to you for the answer so you can have your vindication, so that we know that you're not just a big, dumb football player? Okay, here we go. What'd you get, Sean? And then when you find the distance for 3 seconds, which is going to be a half a 3 squared, what do you get there? 29.4? Negative, yes. Negatives are telling you it's below you and below you. And so what is the displacement, the change in distance? It's going to be negative 78.4 minus negative 29.4. You do have a minus in there, which is it negative 29.4, by the way? Okay. I think that sounds better to me. Negative 44.1 sounds better to me. I was hesitating, going, I don't think that's right when I do it in my head as a rough guess. By the way, Cole?
I read the wrong number.
Oh, okay.
Yeah, I got it.
By the way, in your head, what's 3 squared? This is roughly 9 times 9, 81. It's roughly half of 81. I know the answer's in the 40s somewhere. In fact, it's 9 times 10. It's half of 90. So I would have guessed 45 if I was guessing. So it's going to be minus 44.1. You do have a minus, which is plus. How far does it fall? During the 4th second. Yeah. Negative still, isn't it?
Yeah.
34.3 meters. How far during the 5th second? Even further. I know the answer, Cliff, would be bigger than 34.3 because it's accelerating. So each second it falls a greater distance. We're going to pause here temporarily. Okay. We're going to come back to doing some more free fall examples next class.